Cool. And on that note, if you're interested in any of the sessions that we've done previously, they are all up on our YouTube channel. So we've done DBT, Azure, um, Data IQ, a couple other different tools. So they're all available on our YouTube channel. Feel free to check it out. Okay, share. Okay, cool. Everyone able to see my screen that says Apache Kafka?
Yes.
Wonderful. So we're focusing on Apache Kafka today. Apache Kafka is a streaming solution, so big data event streaming. I started learning a little bit about Apache Kafka over the last couple of years. It's gotten really big lately as modern data warehousing is starting to go a little bit out of style. That like truly structured data warehouse architecture and functionality is starting to not be as scalable as especially large organizations, but even smaller organizations that need streaming and real-time data with things like IoT or streams coming in from from data collectors in the field or different applications. So as we've gotten more advanced as a data society, that modern data warehouse really doesn't encompass all of the needs for organizations that are doing really cool things with data. So Apache Kafka is a streaming event platform. And one of the key things about it is that it has a very small footprint, both in processing and in storage, because of some of the ways that the concurrency and the queues are set up. We're not going to get too deep into that today. I'll talk a little bit about it, but because of the way that the system is structured, the footprint of the tool itself is very minimal. Yeah, so unlike the modern data warehouse, a modern data warehouse is really thing-based. So you have an object, that object is your fact table. From that fact table, you have descriptor objects, which are your dimension tables, and those are each distinct objects within a data warehouse. Event-based data collection is based on logs. So it's not about the thing, it's about the event itself, and then logging of that event that can be accessed as a data point. As I mentioned, they have really great storage capabilities. One of their scalable and reliable features of their storage capabilities are that they have geo-redundancy, they have multi-backup. You can set all these features that ensure that your data is always available no matter what. So if for some reason, your Kafka application corrupts or your whatever you're running on it, like your AWS corrupts or something, there are different versions of that data and that code elsewhere. So all of your stored data is safe. I don't like using this next term, but ultimately this is the closest thing that I think as a data industry we have come to this so far. So real-time analysis. And I like to caveat that often with near real-time analysis. There is always a lag time depending on where you are geographically, how far your data has to travel, how much processing your data has to have done on it. So if you have a lot of transformations on your data, obviously it's going to take longer and it's not going to be true real time. But the key point here is it's not batch file. So there's no more are you beholden to creating a trigger and a schedule that runs a batch once a day or once an hour, or even if you're running something that runs once every 10 minutes, you're lagging behind whatever real data capture is happening. So think stocks, stocks change every millisecond, and even Google's stock Ticker, and I think E-Trade, Stock Ticker, and Robinhood, they're all a 15-minute lag time. So, so you're looking at stock data from 15 minutes ago. If that were instead on an Apache Kafka tool, you would be able to see that more real time, and you'd see events come in and be processed at the time the event happens. And that's really where that real time comes from, is instead of a thing happening, another thing happening, and then the 15-minute time slot ending and then that data being loaded, it's the event happens, it gets loaded and processed. Another event happens, it gets loaded and processed immediately. So really the real time is at the beginning of the process, where everything loads at the time at which it transfers. Oh, and this is a really fun feature that I work with a lot because I do data engineering consulting, and so a lot of my job is transferring legacy and antiquated data warehouses, architecture, databases, you know, things that have been half stood up, and you know, it's like half a data warehouse and they don't want to use it anymore, they want to migrate. There's really easy integration within Apache Kafka to pick up the information from that legacy solution and migrate it into those Kafka event streams, and then migrate whatever application is drawing that data and point that from the database to instead the Apache Kafka stream. So that just makes your transition from, you know, either legacy on-prem or legacy modern data warehouse solutions to the event streaming solution a lot easier. Okay, pricing. So there are 3 plans for Apache Kafka, and I specifically use the pricing for Avian with Kafka Connect. And so if you go on their website, you'll see that there's a bunch of different options based on the different needs of the enterprise that you're using. This one seemed to have the features that, you know, were kind of a median of those available, and the pricing was around the median of what was available. So startup, business, and premium, that should have a star next to it. So within startup, you only have 1 dedicated VM. You can go up to, you know, 1 to 8 CPU per VM. So that gives you the option to be more scalable. So if you're starting out with a small solution, but you know over time it will grow, you can start with 1 and you'll be paying less. And then as you migrate up to, you know, 3, 5, whatever, you will be paying more with each jump. And so what that looks like is, and this pricing also depends on your RAM. So you can go from 4 GB to 32 in the startup. And again, that's really based on how much you want to pay, how much size you need, and how much processing you need. So that goes from, you know, 18 cents an hour to $1.17 an hour for compute cost, which is a pretty good deal. You know, I think that's less than both Azure and AWS processing costs because they are also a consumption model. So you're seeing that it's definitely a comparative price, and then they've estimated out the monthly price that can be used on each of these, and it's, you know, the average use over the point at which you've scaled your solution. You can see business is mostly the same. You can go up to 3 dedicated VMs, but everything else is very similar. Because you can go up to 3 VMs, or because you do have 3 dedicated VMs, the pricing is a little bit higher, but not extraordinarily. And then finally, Premium, 6 VMs. Premium doesn't allow you to have less than 8 GB. So if you're, if you're worried about being a small solution at the outset, Premium is not the way to go. Premium's like an enterprise is trying to, like, GM has all of their IoT that is building all of their different robots and appliances and stuff. All those robots have IoT that they send to a centralized location. That is when you want to have Premium from the outset. Otherwise, you don't need it, especially when you're just starting to use the solution. They do have a free trial. So use the free trial, and then use the startup and see where that gets you with whatever project you're working on, whatever organization you're trying to move to event streaming, and then scale up from there. Okay, like I said, Kafka is a huge break from modern data warehousing. This is a complete shift in the way we think about organizing data. So as I said, data is stored as events and topic logs. So what this looks like is you identify something called a topic. The topic can be anything from this specific application to, these are my customers, and that kind of, if you name your topics things like customers and users and things, you can kind of create a middle ground where the nomenclature of the structure is still very similar to modern data warehousing, whereas the structure itself is not. But you can also do like, you can say like, I want this topic to be every time someone uses this type of event on this application. So every time someone presses add to cart, I want to see this. Whenever someone presses buy now, I want to see this in this different topic. And anytime anyone hearts something but doesn't move it to their cart or their buy now queue, I want to put that in a different topic. And so that kind of lets you portion events out in these different categorizations that require different things. Is there a question? Yeah, so topics can be easily curated for specific applications. Like I mentioned, topics can be identified as, these individual pieces of an application. So as you onboard applications, you can say, well, we have this standard structure and setup for our topics, but this application, this application is very different from other applications we use. It's back-end facing, it's not customer facing. And so we're going to have these different topics instead. And you can very easily, customize that around that specific application instead of going by whatever your standard topic structure is. Yeah, so we talked about real-time streaming. And then one thing that's really interesting about this solution is it has really low latency. So like if you think about a modern data warehouse, even if you do have batch processes running constantly, because they're batch processes, it still takes a long time to load. And there's a lot of processing behind it, and it has to go through significant pipelines to get to the curated selection of or curated section of your data warehouse, which then pushes out to your BI tool, which, it's all very not necessarily complex, but a little convoluted, the way that the structure allows the data to get from the application to the end user. Whereas within event streaming, because of the structure of the topics and events, those are effectively your pipelines. So your pipelines are always running, and they, there's not as much backlog in them because both they're not structured like traditional pipelines. So so you only do transformation at the very end. Everything is is structured in the standardized event format, going from the application to the very point that you do transformation, and it's happening constantly. So that's a really nice feature when you're using important important data points that need to be updated constantly. So like if you think about hospital applications, doctors in most hospitals now and nurses have tablets that they walk around with instead of having a chart at each person's bedside. They have a tablet and they can go and scan the QR code of that person's bed. It pulls up their chart, and it's really important to be able for a nurse to say, this person's blood pressure is really high, and to add that to the chart, and immediately the doctor gets a notification saying like, this is concerningly high blood pressure, please come and help me figure out what's going on. So that can be very important, especially in life or death situations. Okay, so we've talked a lot about the pros of Kafka. I'll just go through them quickly again. Consumption-based pricing is always better. You don't want to pay for something out of the box that you use twice and then you don't use ever again, and you paid, $20,000 for the solution that you never use. Instead, you can, you can onboard really quickly with a credit card and, get off and go running. Next, oh, and I haven't mentioned this, but it is an open source solution. Because it's an open source solution, there's a very big community, which is always helpful, but there's also a lot of modular capabilities that are available both for purchase and some for free. So you can go similar to packages in Python or libraries in R. You can go and purchase or install for free different modules that that can be used within the Kafka solution. Real-time data, and then the default of Kafka itself is designed to enhance as much durability and reliability as possible. So this persistency that I mentioned across geo-redundancy or across multiple platforms, that allows it to be durable and reliable because you constantly have access to that data no matter what, unless there is like a global disaster taking down every single data, every single database in the world. So those are the good things about it. There are a few cons to it. Like I mentioned, this is a whole shift in the way that developers are thinking about data. So especially, if someone's been working on data warehouses and building data warehouses for 20 years and they started with on-prem stuff and they've moved to the cloud and they still build data warehouses in a very traditional way, they then have to look at Kafka and say, I'm going to think about this not as if it's a data warehouse, but a whole different animal. So that could take a little bit of, of more complicated onboarding. Also, there's different backend structures. So even beyond like the even beyond the events and the topics, there's things like queuing, concurrency. So you can like set your own concurrency. You can set your concurrency patterns. So like if you want a round robin versus a hash. And then queuing is like, how do I ensure that my data goes through at the fastest time? Do I want this line to just kind of I know that's going to be slower, so that topic can stay on this single VM, and the others we're going to filter through these other two VMs because I know that they'll be faster, and so they can take turns. So you can customize all of that, and many I would say that many data engineers, especially who have learned the traditional way of data solutioning, have not learned about those theories and those tools before. So it's just, more upskilling of how do I actually build the thing, which is always the easier part, I think, of any new data solution. The harder part is kind of wrapping your brain around how it's going to work. And then the easier part is, there's so many tutorials online, but that is another barrier to entry, is actually using the tool. There's no great auditing system. So like reporting and monitoring functionality through the pipelines, they don't have a great one. It has holes in it. So you would either have to invest in a third-party auditing system or implement your own auditing system. Usually auditing systems are pretty lightweight, so it probably wouldn't be that much of a lift to get an auditing system onto this solution, and probably wouldn't be that much of a financial lift either. But it's just another thing that, like, now we have to use another tool for this, whereas traditional databasing solutions like Azure or Informatica or any of these solutions, they have reporting and monitoring and auditing baked into the system. And this last one is oh, sorry. So this last one, the solution itself, because of the way that events are structured, they're in log formatting. So the log formatting requires every event to be in the exact same format and style. So think of it as like a JSON importer or something like that, where you have this structured hierarchy and that schema is not mobile. So you can't have schema drift, you can't change the structure of that within a given topic. So if an event is assigned to a topic, the log of that event needs to follow that exact structure. Whereas in traditional databasing and data warehousing, you can often it's not a great move, but you can often work in things around like case statements and where clauses and stuff to make sure that you can be a little bit flexible in your data ingestion. Whereas here, data ingestion is very strict. If there's a change in data ingestion in a single event, that log will be errored out and it'll go into an error log. And if you have a new topic that needs to be monitored, that needs to be logged, you have to create a whole new structure for it if it's not the same structure as an event that already exists. So you can make templates and stuff, but if you need something new, you can't use that template and scale off of it. You have to really build the thing customized to the event that is happening. Okay.
Amanda Chase posted a few questions in the Q&A, if I can read those. The first one is, do cloud service providers such as AWS provide streaming services? And if so, how do those compare to Kafka?
Yes, they do provide streaming services. Their streaming services are structured a little bit differently because Kafka, so the way that Kafka works is it sits on top of a solution. So you still need to have like an AWS or an Azure or something to sit the Kafka solution on top of. And so like the relationship between the two is very different. I would say that compared to like Event Hub, which is Azure's, I don't remember the name of AWS's, but I know they have a streaming. It might be Cassandra. But they're definitely, this is a distinct and focused event streaming solution, whereas those tools, especially the big players like AWS, Azure, and Google, they are looking to get their hand in every pot, kind of, and so they don't go as deep as this solution does.
Then the other one was, does Kafka automatically extract the metadata of the event, or do you assign attributes and then it kind of fills in the blanks?
So it depends on the application and the ease of which that application is handshaking its metadata. From what I've seen, the metadata will automatically be ingested into the log itself. So the log will consist of not only the data that you're collecting, but the metadata itself. I have also seen a few people have issues with that, and so they create alternate topics that ingest the metadata separately from the event that is happening. And so there'll be some sort of key across the two. Ultimately, that's not the way that Kafka was set up to be used. Like the idea of keys across topics is kind of contrary to the event streaming solution they've set up. But you're able to do stuff like that where you can kind of hack it a little bit, and if your application isn't isn't as integrated as you would like it to be, you can create those different topics for the metadata.
Thank you.
Of course. Any other questions? Okay, cool. So, I was gonna go through the initial setup of Kafka, like a Kafka quick start. I don't know if we'll have time for it, but I can walk you through what that looks like. So, and then what I'd like to do is have a discussion between the four of us. There's this really interesting idea going around lately. Oh, there it is. About like hybrid streaming solutions versus modern data warehouse solutions versus 100% streaming solutions. And I think it would be really interesting to have a conversation about that. So if you guys are game, we'll go through this quickly and then we can talk about that kind of stuff. Okay, cool. So Kafka runs right from your command line. So do your command prompt. Often you're going to want to run as an administrator because you're going to have to install stuff. So let's start with a couple of these, I guess, and we'll see. I have not done this yet, so we'll see how it goes. Okay. Yeah, okay. So I'm not going to run this in command line because this version is an old version and I would have to download, save, and do all this stuff. So, so we'll just walk through it. You know, this command downloads the latest version, but you would have to look up the latest version. So Okay, so they're in 3.3.1. And then you have to download the release and extract it. So so download the package, go to your directory, and then starting the Kafka environment. You can do Kafka in a few different environments. So this is no longer in your command prompt. That's just to install the package. I haven't used either of these, so I can't give an indication of which is better, but I think either one would work. And then from there you start building your topics. So you start building your distinctions that you want to see your data categorized into. You write events into it. So these will be like test data, bad data events that you're writing into it to just make sure that the structure and hierarchy of your log works by pulling it in and reading the event. The pricing that I showed you was for Kafka Connect, so that would allow you to do this, which is installing that Connect plugin, and then after this it's pretty standard stuff. It's testing stuff, bringing in objects. So you can see here these events are standardized. So, you're looking at the data types, whether it's optional, and then you have that variable metric that you're seeing come in differently with each event. This processes your logs. So they are functional through a BI tool or an analytics tool connected to R, whatever you're going to be using to do analytics on this. And then you always want to close your Kafka environment. Ashley and I were having a conversation about this at the beginning of the call, but we've both found it very easy to forget to close your environment and turn it off. And costs add up quickly. So especially if you're working with streaming data, you want to make sure you terminate your environment every time you're done using it, because if you actually attach it to an application and that streaming pipeline is running, you will get charged for every event that runs. Yeah, so I know that wasn't super thorough, but just an overview of how to get that up and running. Oh, I see Jocelyn has a question. My company is in the States. Was that a question for everyone though? We could go around the room and ask. Okay. Yeah, my company is in the States. I'm actually in New York State, and we're fully remote. So I have a coworker in LA. We have people around the country. We are solely US right now though. So we don't have anyone living outside the States, and we don't have consulting operating functionality outside of the US.
Is your company Kafka, Amanda?
No. If my company was Kafka, I would know a lot more. But no, I work for a consulting firm called CTI, and we're like a boutique data consulting firm.
Okay. Sorry I got here so late. I wish I could have attended earlier. For the question, I'm from New York. I'm the Director in Reporting and Analytics for a Syracuse-based health insurer and healthcare provider. Data ingestion is a little bit outside of my wheelhouse, but I loved the last data tools you guys put on a month or two ago, and I plan on checking them out from now on. So thank you.
Yeah, you definitely should, because data ingestion, that's where you can really start to cut your costs, which I know, especially in healthcare, We talked a little bit about the data that healthcare uses and how much data there is, like how many events and logs happen every 10 minutes, every minute. So anywhere you can kind of cut those costs is really helpful, and learning your ingestion solutions that will help you get there.
I was actually speaking with someone earlier this month who has a gripe with their current vendor because the data refreshes every 2 days. You have people with tablets out in the field constantly updating. Sorry, I said 2 days, twice a day. So
Okay.
you can't really see who's missing their rounds or whatever's happening during the day. So a solution like this would be more appropriate for what that is. And then now I'm wondering how much of a lift would it be? Because like practically, it's not in the budget or the time of anyone to move our system over to Kafka unless it could deal with a whole lot of solutions.
So it is very integratable. You know, it has a specific integration tool that that is meant to be scalable across legacy applications, antiquated databases. And actually, yeah, why don't we start that conversation? Because I'd love to hear your thoughts on, you know, there are arguments right now for the modern data warehouse solution, which is, you know, what we all know and love, a hybrid of event streaming and data warehousing. And then there are people arguing about 100% streaming. So any data that you get, whether it's data that inherently like on its own updates every couple of days because there's not much input, all the way up to something that has a log running every second. Yeah, I'd love to know your thoughts about that, especially in healthcare.
I have a question. So how does Kafka do deduplication?
So there are built-in tests, and so especially around duplication, because it's not built on primary keys, they do identify duplicates, and then that log is not processed. So if that exact same log with the same timestamp and everything has already been processed by the system, it will not be processed again.
So for a streaming application, how about late event?
How do you mean?
A late event that is running late.
So like you expected the event to happen at 1 p.m. and instead it's happening at 4 p.m.
So I mean event that is coming late should be in the previous time track.
Oh, okay. So so that's kind of one of the use cases that Kafka takes advantage of, because it's not running batches, it's not happening you know, it's not happening in batch files. So your event might be late because someone didn't enter their data in time and they waited till the end of the day, and then that's when your event happens, is when they press submit or something. That event will be streamed at the time that that submit button is pressed. So at the time that the event has happened, the log will be logged. So that's kind of how they work around late events. It will still be late according to your standardized system, but it's you know, it's going to end up being a data collection issue that you can uncover and understand why that event is being late as opposed to not processing it.
So also like if there's an incident that you need to reprocess some data, how do you do that in the streaming?
So that I don't know. There is a way around it, and I haven't dug deep into it, but I know there's a way to get around it. I think there's like some back-end coding that you have to do to remove the logs that were within whatever time frame you were processing, or whatever, whatever characterization they were processing, remove them, and then rerun those specific events. I don't know how they get around, there are backups, but those redundant backups would also have the same logs, and that event isn't going to run again. So I'm really not sure, but could do some research into it and let you know. Any other
And so
questions?
yeah, you mentioned the timing sensitivity for healthcare. It's interesting because some of it moves at a glacial pace. For example, today I'm working on a regulatory item for 2018. Sometimes they want time for a lot of data to come in, and then Albany sits on it for a while, and then you get it back. So it doesn't matter for that. But then you have things like we have telehealth service. So you'll get people get emails like, warning, someone just gained 5 pounds in the last day. Warning, blood pressure spike. And that comes across more than twice a day. And then we have people on their tablets like, where am I in the town? What am I doing? And that only comes across twice a day. So we have all these different systems. We have too many systems. And the data is processed at different rates. Something like Kafka, just thinking about what it can do, the fact that you need to, well, I mean, you need to set everything up. To me, Kafka seems like a more, like, almost like a blank spreadsheet, like a blank canvas of data ingestion, whereas we purchase expensive software from our vendors that's tailor-made for everything we need. I wonder if it would make sense to remove a portion of it from that, something that is very time sensitive, and funnel that small bit through Kafka somehow, and then pay the fee-for-service pricing tier it has. Just thinking out loud.
Yeah, you could definitely do that. If there's always the, people work in a Microsoft shop, or they work in an Apple shop, or they work in an Amazon shop. So if that is an issue within your organization where they don't want to use a different tool, depending on your vendor, large data solutions have event streaming modules that are built into it. So like if you're using Azure, Azure has Event Hub, which is their event platform. AWS has one, Google has one, where they focus on event streaming. They're just not as robust or customizable as Kafka is with their focus on event streaming.
I wonder if you think it would be practical. Yeah, sorry.
Oh, sorry, no, go ahead.
I wonder if you think it would be practical if, suppose you've got 100 people out in the field and they all have their tablets, and their tablets are using the specialty software that goes directly from what they enter to an off-site database, and then we use a mix of canned reporting and Tableau to get information out of it. I wonder if there would be a way to just take a subset of that data, and somehow you'd have to get it out of the flow, out of that proprietary flow to Kafka that would let us work with it in real time. I wonder if that's possible, how you would do that.
Yeah, it definitely depends on whether you're managed or self-managed. So if you are managing your data solution, if it's your data warehouse and you're connecting to the application and pulling that data in, that makes it a lot easier, because then you can you can set up the environment with Kafka, figure it all out, do your dev test and QA. It does take more development than a lot of other solutions, so it's not point and click. There are IDEs for it in the different modules, but the majority of it is code-based. So you do have to have technical developers on it, but have that all set up, do your testing, move it to production, and then have that be your pipeline, and then cut the source to your data warehouse and just, have that running. So that's the option if you own your data warehouse. If you're being managed, it's a little bit more complicated. You have to work with your vendor to reroute that application. And if it's an application like, I don't know what you use, but a lot of hospitals use Epic. And so if it's something like Epic, Epic owns its own database that it pushes all of its data into and manages for all of its clients, which is a lot of its that's a lot of its revenue generating structure is consumption cost. So they might be less willing to work with you to move to an event streaming platform.
Okay, thank you. It's way more niche than Epic, by the way. And the problem is I can't.
Oh, yeah.
I'll shut up in a second, Chase. I can't link to the database obviously because the database is what's not updated. If that worked, my reports would work. So, okay, thank you for your thoughts.
Yeah, of course. Go ahead, Chase.
Yeah, so I'm just getting barely into like the Apache world, and so I've been toying around with Airflow, and I've noticed that like it's really easy to integrate with Python. It kind of like gives you automatic DAGs. So I was wondering, like with Kafka, does that automatically like go with Python and create those streaming DAGs, or is it like a manual process?
So it does integrate with Python pretty well. I don't know about the streaming tags, but within topics you can create various tags. So so that might be a roundabout way of saying yes, it does the same thing, but just kind of through different functionality. But if it's something that's available on Apache or on Airflow, I would imagine it's available on Kafka.
Sorry, I meant DAGs, like directed acyclic graphs.
Oh, I do not know.
Okay.
Yeah. Yeah, I would have to look that up.
I think he means a DAX.
Sorry, Jocelyn?
I think he means a DAX in Airflow.
Oh, okay. Um, okay. Yeah, I think it's an interesting comparison. Something quick I just found is, this article this is a private third party firm, but they did a comparison that seems legitimate. So you could look into the differences between the two on that. I haven't worked with Airflow, so I don't know the intricacies of it.
Okay, yeah, I'll have to look into that. Thanks.
Okay, any other questions? Thoughts, comments?
Not for me. Thank you for this introduction.
Of course. We are going to be we're going to take a break over the holidays, and then we are going to be working on developing a new arc of a topic. So if anyone is interested in sharing ideas, please feel free to reach out. Ashley and I are both founders on our LinkedIn and on our meetup. So if you go there, you can reach out directly to us. We'd love to hear your thoughts on what you would like to see happen next. A workshop, speaker sessions, whatever. Okay. Thanks, everyone.
Yeah, thank you for your
Thank you.
time.
Thanks. Bye.
Okay.